Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In today's episode, we're focusing on buffer overflows, SQL injection, and other common software flaws, critical vulnerabilities that every cybersecurity professional must understand, detect, and proactively mitigate. These types of vulnerabilities are often exploited by attackers because they're both widespread and highly impactful. Many of the most serious breaches in history have occurred not because of zero-day exploits or sophisticated nation-state actors, but because of simple, well-known flaws in application code that were never properly addressed. As a certified information systems security professional, you are expected to recognize these weaknesses, understand how they're exploited, and know how to implement strategies to eliminate them from the start. Let's begin with buffer overflows. A buffer overflow occurs when a program attempts to write more data to a memory buffer than it was allocated to hold. Buffers are simply blocks of memory used to store data temporarily, such as strings, arrays, or user inputs. If the program does not verify the length of the input, it can overwrite adjacent memory regions with extra data. This overflow can lead to various problems. At best, it might cause a crash or data corruption. At worst, it can be exploited to execute arbitrary code, escalate privileges, or gain unauthorized access to system resources. Attackers often craft inputs that overflow a buffer and inject executable code directly into memory, redirecting execution flow and gaining control over the application or system. Buffer overflows are especially dangerous in low-level languages like C and C++, where direct memory access and pointer manipulation are common. Legacy applications written without modern protections are particularly vulnerable. Understanding how buffer overflows work is the first step to prevention. These flaws remain prevalent because of unsafe programming practices, insufficient bounds checking, and a lack of secure coding awareness. Let's now explore how to mitigate buffer overflow vulnerabilities effectively. The first and most important control is rigorous input validation. Always verify input length, type, and format before using it. If an input field expects 20 characters, enforce that limit and reject anything longer. Use bounds checking functions that are specifically designed to avoid overflows. For example, avoid dangerous functions like gets and stripe and CNC and CNP, and instead use safer alternatives like forget and NSN. Where possible, use memory-safe programming languages such as Python, Java, or Rust. These languages include built-in protections like automatic bounds checking, type safety, and managed memory, significantly reducing the likelihood of overflows. Deploy static application security testing, also known as SAST, to detect potential buffer overflows in source code before it reaches production. Combine this with fuzz testing, which inputs random, unexpected, or malformed data into programs to uncover crashes or memory errors. Use compiler-level protections like stack canaries, address space layout randomization, and data execution prevention. Stack canaries insert known values into memory and check them before function returns. If the value changes, it signals a potential overflow. ASLR randomizes memory layout, making exploitation more difficult. DP blocks execution of code in data-only memory regions. And finally, train your development teams. Developers must understand the risks and be equipped to use safe functions, manage memory responsibly, and design code defensively. Let's now shift to SQL injection, another high-impact vulnerability that has plagued web applications for decades. SQL injection occurs when an attacker submits specially crafted input that alters the structure of a SQL query. Instead of treating user input as data, the application mistakenly treats it as part of the query logic. This allows attackers to view or modify data they should not have access to, bypass authentication mechanisms, delete records, or even gain administrative access to the underlying database system. In some cases, SQL injection can be used to access the operating system itself. These vulnerabilities typically arise when user inputs are concatenated concatenated into SQL statements without proper validation or parameterization. For example, allowing a user's login credentials to be directly inserted into a query without sanitizing input enables attackers to manipulate the query and gain access. SQL injection remains one of the most common and dangerous vulnerabilities, despite being well understood. Its persistence highlights the importance of consistent, enforced, secure coding standards. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyberattacks.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now review best practices for preventing SQL injection attacks. The gold standard is to use parameterized queries or prepared statements. These techniques separate user data from the SQL command, ensuring that input is treated strictly as a parameter, not executable code. Next, implement strong input validation. Validate and sanitize all user input before it reaches the database. Enforce expected formats, character limits, and data types. Use allow lists where possible to restrict input to only known good values. Enforce least privilege within your database. The application should connect to the database using credentials with only the permissions it needs, nothing more. For example, if the application only needs to read data, it should not have delete or write access. Use dynamic application security testing, also called DAST, to test web applications for injection vulnerabilities in a running state. Combine this with code reviews, SAST, and manual testing to build comprehensive coverage. And train your developers. Many SQL injection vulnerabilities result from ignorance, not malice. Educating your teams on secure query construction, input handling, and proper database interaction is key to long-term prevention. Let's now expand our focus to other common application security flaws. These include cross-site scripting, or XSS, which involves injecting malicious scripts into web pages that are viewed by other users. XSS can steal session cookies, deface content, or redirect users to malicious sites. Insecure deserialization is another serious risk, where attackers manipulate serialized data to execute arbitrary code on the server. This often arises when applications trust user-provided data without validation. Broken authentication and session management is also common. If sessions are not managed securely, attackers can hijack user identities, bypass logins, or escalate privileges. To address these issues, organizations must use comprehensive testing frameworks, automated vulnerability scanners, and integrated threat intelligence. These tools help detect flaws before they're exploited. Clearly define secure coding standards, enforce them across all teams, and embed them into your development lifecycle. Conduct regular vulnerability assessments, penetration tests, and full security audits. Focus on applications, APIs, middleware, and back-end systems alike. Ensure that your development environments are secured, manage access, encrypt sensitive data, and prepare for rapid incident response in case a vulnerability is discovered in the wild. Let's now turn to continuous improvement in application security. Static policies alone won't protect you in a dynamic threat landscape. You must regularly review and refine your security strategies based on new technologies, evolving attack vectors, and shifting compliance requirements. Use incident analysis to guide improvements. When a vulnerability is discovered, trace how it occurred, how long it went undetected, and what safeguards failed. Use these insights to update controls, improve training, and revise workflows. Leverage metrics and feedback. Track the number of vulnerabilities found per release, mean time to remediation, and testing coverage ratios. Use this data to inform investment decisions and process improvements. Collaborate across teams. Developers, testers, operations, security, and compliance must work together. Create shared accountability for application security, not just a checklist owned by one group. Maintain continuous training. Keep developers updated on the latest secure coding practices, threats, and tools. Encourage certifications, hands-on labs, and real-world case study reviews. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of buffer overflows, SQL injection, and common flaws, and will consistently support your journey towards CISSP certification success.